Great events. Amsterdam, perfect city.
Move back to the future.
So yeah, we're going to move up a level, I guess. You guys have been bamboozling me with hardware because I'm a software person. And us software people always think the hardware's the easy part, the software's the hard part. Actually, I think you've changed my view of that this morning. So there's a lot of complexity in the hardware. And actually, in reality, it's the two together that actually are going to help us create the innovative solutions. We can't have one without the other and vice versa. Within IBM, or many moons ago, we used to talk about smarter planet, and that's actually what a lot of the types of solutions we're talking about here. And in smarter planet, actually, the way we sum up what IoT is about, in fact, the three key aspects to it, there's instrument, that's actually where the sensors go, where you're actually getting the data. Then there's interconnect, which is how do we move it from somewhere where you're actually collecting the data to actually where you can make use of it. And there's the intelligence. That's actually what you're going to do. That's how you're going to make the business, how you're going to make your money out of the data. So I'm actually going to be focusing on this presentation on the interconnect piece. How do we move the data around efficiently based on all the sort of constraints we have in the network? But actually, IBM's real focus is in the intelligence, but you'll be glad to know I'm not talking about that today. So to start with, it is really about MQTT, and I'm going to tell the story of MQTT. In fact, it is 20 years old this month. And the reason I'm actually going to go back is actually a lot of the reasons we invented it 20 years ago are still relevant today. Now, the thing that is really pleasing, this is actually, I'll explain MQTT in a minute. It's really pleasing is Eclipse did a study of developers saying, what messaging or what connectivity protocols are you actually using in your solutions? And there's a whole range, MQTT, HTTP, CoAP, AMQP, and you can see easily in the lead and still growing is actually MQTT. MQTT very much sits alongside HTTP, and you have a choice as to which one you use in a lot of solutions, and I'll explain why in a minute. Now, the interesting thing is HTTP is actually dropping down a little bit, but that's actually not because of the uptake of MQTT, it's because of HTTP2. So you can actually see HTTP2 over here, if I can find the right button, is actually growing. The other one that is growing, and actually shouldn't be a surprise, is AMQP, because a lot of the messaging, when we're going into the enterprise or into the cloud side, a lot of solutions are using AMQP at the back end. So before I sort of go into MQTT, I just want to give a quick definition of how we talk about the Internet of Things. The Internet of Things isn't new now. We've been talking about it for 6 years, but actually the Internet of Things is even older than that. I've been doing it for 25 years, and there's solutions 50 years old and longer. But there's some clear differences between the old solutions and what we hope the Internet of Things will become when we get the billions of things connected. And the way I like to talk about it is the Internet of Things is the evolution of the World Wide Web. And on the web, there are really two participants. There are people, all of the people in the room here, that are going to interact with the web and talk to the second participant, which is web services. And a web service is anything like your bank, a shop, a search engine. And the key to the success of the web is there's a single connectivity protocol that pretty much we all use to talk to all of those web services. It is that protocol there. It is HTTP. 99% of all traffic for business to consumer on the web is HTTP. Everybody uses it. It's open standard. It's open source. There's lots of implementations. So all the developers can build to the same standard, which is why we've ended up now with so many different services and so much business happening on the web. The only snag is HTTP has a couple of drawbacks when it comes to the Internet of Things and the types of devices we're talking about in a moment, this morning. HTTP implicitly is a request-reply paradigm. So you send a request and ask a question, and it gives you a reply. The snag with that works okay in the web when you're actually asking a service to do something for you. But actually, with the Internet of Things, what we're typically doing is sending an event, something's happened, and there's going to be typically one or more people wanting to listen to that event. Now, for the people listening to events, so take an example, someone's pressed your doorbell, and I want to know that the doorbell has been pressed on my phone. If you were to use HTTP, you'd have to send a request to the server saying, has the doorbell been pressed? No. And you do it again. It's a request reply. So you keep polling. Now, if you imagine with your battery on your phone and you're polling continuously, your battery's not going to last very long. So it's very, very inefficient for event-oriented systems. So the simple way to differentiate MQTT and HTTP is request reply. MQTT is very much an event-oriented protocol where you publish events into the cloud and then 0, 1 or more subscribers, applications can say, I'm interested in that data, and they can go to sleep. And basically, when there is data for them, the data is pushed down to them. There is no polling in that at all. So hopefully what we end up now with, the Internet of Things being the evolution of the World Wide Web, we end up with a third thing. People, services, and things. And a thing can be anything from a little sensor, a tracker like this morning, a sensor on a river estuary, sending in a couple of bytes of data, maybe every half a day, all the way up to a Rolls-Royce jet engine, and they spit out terabytes of data an hour. But the key to the success of the Internet of Things is actually getting it connected up like the Internet using a small number of protocols. It's never going to be it's never going to get down to one, but a small number of protocols. And HTTP and MQTT together are looking like the de facto standards out there now. So I'm going to give you an intro into MQTT and then hand over to Nick to talk about and actually bring it to life and how it's used in inflow. As I said, MQTT is 20 years old. This month, the 22nd of this month, so I was going to get you all to sing happy birthday, but we haven't got much time for that now, but maybe later on. The key we said right from day one with MQTT is it needs to be open. Because if anything's going to be used across the world, it has to be open. So MQTT basically is now an open standard and has been since 2014. It's an international standard with ISO since 2016. And there are many, many, many open source implementations. I'm actually a committer in Eclipse in the PAHO project. So again, we've got all the building blocks, like with HTTP, that enable everybody to use it with a low cost of entry to actually using it, and actually a low cost in terms of actual dollars. So where does MQTT come from? It actually came from, if you like, a precursor to IoT, a SCADA project, supervisory control and data acquisition. Very simple project. This is what the solution looked like before. It's basically the control of what goes through pipelines. And I thought that was a really simple, you put something in one end of a pipe and it comes out the other. It's really complex, like the hardware this morning. So there's all sorts of control points on the pipeline where they have control stations and valves and sensors. And what they were doing before, they were using a SCADA system at the data center. And it was polling, like I talked about HTTP. It went out to device number 1 on the pipeline. Give me your sensor readings, came back. Go out to device number 2, came back. Many limitations, as it said there. This was over a satellite network, which was expensive. They saturated the satellite network. They were running 100% CPU on that Valmet SCADA control system. And it was limited to only the control system getting access to the data. And the big problem from the business perspective was that was sort of okay, but they needed to extend the pipeline, and they couldn't because they'd already saturated the network and the CPU. That's actually where IBM and a partner of ours, Arcom System, got invited to come and solve that problem. How do we extend our pipeline? That is actually where MQTT was invented for. So in here, what we do, out on the pipeline, so I should be using the pointer, we have basically field units out here where each one of these controls 20 different devices. First thing to note is it's no longer the central system that is talking directly to and initiating a conversation to the field unit. In MQTT, the initiation, and this is really important from a security perspective, is we always initiate connectivity from the thing at the edge of the network. So we establish the connection. And you'll notice we've inserted, this is original terminology. It's basically an MQTT server. So we establish a connection to the MQTT server. And this guy basically, for all intents and purposes, is doing its control logic, taking sensor readings. But now it only sends information when a certain amount of change has been made. So maybe the temperature or the flow rates change by a certain amount. So report by exception. So we only send data absolutely when necessary now. We publish it up. The device can also say, I'm interested in control command changes. So if we want to change the configuration, basically it sits there waiting. It's no longer polling the center, and the central system can publish information down. So we can publish information in both directions. And in both cases, each side can subscribe to either the data coming from the pipeline at the business end of the network over here, or for control commands over here. So long story short, with the MQTT protocol, we can now very efficiently get messages going back and forward. And the most important thing from this solutions perspective, we could now extend the pipeline pretty much ad infinitum, because we are no longer saturating the satellite network or the running 100% CPU over here. And there was an unforeseen benefit, and we know this in enterprise computing across many years. In the past, the only part or business unit within the company that could access the data was actually the operations department. Now, data, you might not think about up front, but a lot of that data that comes from that pipeline can be used by other departments, like the maintenance department, like the billing department. It used to be when they basically, the outlet from the pipeline into a customer's depot, between it arriving in that depot, it was a 3-month period before they actually got billed, because it was all done by paper. Because this guy spit out a paper report that went into the billing department, and they then entered it into their billing system. Now, literally, the instant a delivery has been made, an event comes into the MQTT server here, and as well as the SCADA system getting that data, the maintenance system actually accesses that data at the same time. So that's another key aspect of the Internet of Things. The key value is in the data itself. Make that data available to who can get value from it in a secure, controlled manner, I hasten to add. So again, this is sort of the constraints that we were designing, or the design goals for MQTT. And this was 20 years ago, and a lot of them still hold true today. Basically, constraints of the network. That satellite network was very low bandwidth, high latency. In fact, the cost of using the network's important. We were actually told when we came into this project, every byte you send costs us $1 million a year. Now we were going, that can't be the case. But because they were polling all of the devices on a regular basis, the cost literally to get an actual piece of data ended up across all those devices being exceedingly expensive, which is why we actually kept that price point in mind when we designed MQTT. The amount of bytes we send was really important. And again, if we're going to low power, wide area networks now, that is still really important. So those constraints still go. The constraints of devices at the edge of the network, there still are very low power, low memory devices that we have to take account of. I've already talked about the loose coupling, making sure data can be given to whoever can get benefit from that data. So not just locking it into one application. Different qualities of service for message delivery, but the key was, and 10,000 is probably a low number by today's standards, but we wanted it to scale well, back up to 10,000 devices, which is a number on that pipeline. Now we're talking hundreds of thousands, millions in a lot of cases, like smart meters. And really, really important, and I'll put my hand up in IBM, we used to develop software that's really complex, that were actually you needed to be a rocket scientist to use. It's really clever, but quite hard to use. Just with HTTP, MQTT is actually really simple for developers to actually use, and there are a lot of open source libraries in all the different languages. I thought I'd put a few examples of how it's been used across the years. This is actually the first, almost the first practical use after the pipeline that we did as a home hobby project. And that's the reason I love the Internet of Things. It's not just about big business. Hobbyists can use all this technology as well. This was one of my colleagues. He lives in an old house where he had a problem with mice. And actually getting to the mouse traps, they were in awkward places. So he didn't like having to do that. So he wanted to automate the detection of the mouse in the trap. So he borrowed a SCADA control PLC, made a very simple trap with a make and break point on there, so if the mouse goes in there, it breaks the contact. The control unit picks it up, and it published an MQTT message into the cloud, which then resulted in sending a text message out to his phone. Really simple, but really practical. And by the way, that is now a commercial solution. In the UK, Rent-A-Kill actually have implemented a remote monitoring of their mouse traps. Really practical, because if you imagine, they have to drive out to all the mouse traps, lay them down, and then they have to continuously go and check them. Now they can do it remotely. The protocol, I'm only going to go into it very briefly. It is very, very simple. It is publish, subscribe. So literally, you have somebody has some data or an event they want to tell us about, so they publish it. It goes to an MQTT server, and I'll explain topic in a minute. And then 0, 1 or more applications, people can say, tell me I'm interested in that specific type of event, that class of event. If there's no one, the message just gets discarded. If there's one that's interested, just that one person will be given it. If there's multiple, everybody is, or that's expressed an interest is given that data. So it's publish, subscribe, it does that decoupling. It's really, really key. We talked about the cost per byte. $1 million per byte was really important. So we made, oh dear, excuse me, wrong button. Where's back? There we go. The fixed header is 2 bytes. The variable header, as it says, is variable, and that comes down to the topic, which I'll talk about in a minute. And then the payload is as big or as small as you like. And in a lot of solutions, we actually used to binary encode the data to keep the size down, to optimize it going across the network, and to keep the price down. The protocol itself, under the covers, is really simple, and it's only got a few verbs. So you connect, and it gives you an acknowledgement. Once you've established the link between the device and where you're sending the data to, I can say, tell me about, I'm interested in a certain class of message, and that's subscribe. And if I'm only interested in waiting for messages, I can in effect go to sleep. I don't have to do anything else now, unlike with HTTP. It will basically deliver that message. And there basically is a heartbeat, a ping request, a ping response, which basically makes sure we know the device is still happy. Publishing messages, we do different qualities of service. So sometimes you can have messages which, in principle, I don't really mind if they don't get there. So that's a QS0. I've done it again. We just do a simple publish. If it gets to the other side, great. If it doesn't, we don't mind. And actually, on reliable TCP-based networks, unless the actual TCP socket breaks, it will get to the other side. But then there are 2 other qualities of service, 1 and 2, which add reliability to the delivery of the message. And then there's a disconnect, and it is that simple. The key to MQTT is the topic structure. So the topic is basically how, when we publish a message or we subscribe for a message, we identify it. And it is very simple. It is just a topic hierarchy. So here we've got a hierarchy, which is fruit. You separate it with a slash, so fruit/grape. And then we've broken it down here, red or white. So you publish to the absolute topic, fruit, grape, red, when I'm saying about the red grape. But as a subscriber, I can subscribe to a very specific topic, and it will give me just the messages for the red grapes in the case of this. Or if I can wildcard it, and there's 2 forms of wildcard, this one says, give me anything that is related to fruit, or this one, anything that is related to grape, red or white. So it's very flexible, it's very powerful, and with anything where it comes power, you have to be careful how you use the topic structure. In fact, what you tend to find is most IoT solutions, like the IBM one, which runs in the cloud, they tend to constrain the topic structure, so you can't tie yourself in knots. I thought I'd give a few examples of projects we used, and again, these aren't ones since the IoT was formed. These are actually ones I actually worked on in the between 1999 and about 2010. A couple of car projects. I worked on the very first ever, I've done it again, there we go, pay-as-you-drive insurance scheme. So a lot of youngsters in the UK, it's really expensive for them to drive once they've passed their test, because their insurance often costs more than the value of the car. So if they can prove they're a good driver, then actually they can reduce the cost of their insurance, and they do that by putting black boxes, telemetry units in the car. And the early one that I worked on used MQTT to deliver the speed, where they're driving, how heavy their foot is on the accelerator, and then that goes back into the intelligence at the back end, where they optimize the cost of that insurance based on their driving habits. Another one is the hire car, but one where you basically just pick it up just down the road. So you book it on your phone. It says, yep, the car's just down the road, opens the garage up, you go in, and MQTT is used in the car so that when you approach the car, it knows you're turning up at the car. And it displayed a unique ID in the window that had come from the server via an MQTT subscribe. You type the code into the phone, and if you get the right code and it knows you're stood next to the car, it unlocks the car. And that's all done with MQTT. And the trick being there is no latency. It's instant. There is no polling in there. A virtual power plant. So this one, we were controlling controlling devices in people's homes. This was in the US, where they often have brownouts and they need to reduce energy consumption. And the way they reduced energy consumption was they said, we'll get the homeowners to allow us to control the devices in their home. And they said how much we can control. The more we can control, the more money you could save. Long story short, the homes send information back to the virtual power station with MQTT. If they decide they need to reduce energy consumption, they use MQTT to send control commands to the home. Since I worked, that was a startup company, it's been taken over 3 times by bigger and bigger companies because they love the solution. One of my favorites, and again, this was in about 2003, company in Canada designs and make pacemakers and defibrillators. And before we did this project, the patient had to go into the hospital on every few months or every 6 months, depending on the patient, to have the heart or have the pacemaker actually checked. And in some cases, they were flying a day to fly in, a day to fly out, because this was in Alaska and Canada in remote places. So not friendly for the person to go in, very expensive. So anyway, they came up with basically a near-field communication way to actually read the data from the pacemaker. And what they now needed was a way to efficiently and reliably get the data from the gateway device in the home, here across to the back-end analytics. So now when the patient is near the reader, it reads the data from the pacemaker and uses MQTT to publish the data into the hospital, where we actually run analytics on there. And if there is any sign of a potential problem, then the clinician's actually alerted. And I will tell you, the network there literally fell back to almost bits per second, not even bytes per second at some time. So it was a really dodgy network. This is an assisted living. People ask me, what do you think is going to be a really killer solution for IoT? There isn't a single one, but actually people keep saying smart home. Smart home's a long way to go because of all the micro ecosystems like Apple wanting everything to be Apple, etc. But actually assisted living, so smart home for the elderly, which is how do we keep people in their homes for longer, my belief is that's going to be quite an important and near-term success factor for the Internet of Things. So smart home for the elderly. We did this back in about 2008 in a place called Bolzano in Italy. So sensors in the home to get peace of mind that we know the person in the home is okay, they haven't fallen, the temperatures and everything all okay. It gives peace of mind to their family and peace of mind to the carers. Right, a little bit more patterns, best practice. So a lot of people, particularly the cloud providers, say, send all the data to the cloud. Well, actually, that doesn't make sense in a lot of IoT solutions. So I've drawn on here what we refer to as a sensor area network. And all that is, if it's sensors on a person, that's a personal area network. So these devices talk to a gateway, and that gateway might be a phone in a personal area network. A vehicle area network might be a black box telemetry, like in the pay-as-you-go insurance. Home area network might be your router, but you basically have a network at the edge, and there are already thousands of darn protocols out there that those devices talk, and actually half the thing of those gateways is to do that protocol translation. We absolutely use MQTT across the wide area network to get the data up to the central systems, which might be cloud, might be enterprise, and also to go down to when you want to visualize and respond to messages. Again, we use MQTT down to those devices to do that. And just to break that down a little bit more, we have devices which directly talk to the MQTT server in the center, and vice versa. But in the case we've got this edge network, and edge network's really important because if you think, if the connectivity is to break from here, the thing at the edge can't talk to the cloud and it may not be able to run. Whereas I can put control logic like my smart home logic or my smart vehicle logic or my factory logic can go in the edge gateway. And if that connectivity to the cloud breaks, I can still run autonomously. I don't want my vehicle to stop just because I can't talk to the cloud. You want the thing at the edge to carry on running autonomously. And what you're doing at the enterprise, the cloud side, to add value to it. So doing things like predictive analytics, which you may not have the power to do at the edge. So we can actually, a lot of solutions do MQTT into an edge box, run a little MQTT server. There's lots of open source MQTT servers out there and bigger MQTT servers at the data center. But you also, as there are lots of protocols, standard ones like we heard this morning, Bluetooth, Zigbee, Z-Wave for the typical home, Modbus, Fieldbus, CAN bus, there's loads of them. This box here ends up with a lot of protocol adapters that we then have our little message bus here, and where necessary, we then bridge those messages up to the cloud. Anyone use Node-RED in here? Oh, I got a good smattering of hands. So Node-RED actually came about as a tool to very quickly build MQTT applications. Since then, it has just grown phenomenally. In fact, yesterday we shipped the first formal version, Node-RED 1.0, and there are over 2 million downloads of it. Very quickly, Node-RED is an authoring tool for creating applications. And literally, you drag nodes onto the palette, you wire the nodes together, and you build applications literally in seconds. And actually, you will see a version of Node-RED, or actually running a little bit later on in Nick's demonstration. All I would suggest is, if you haven't played with Node-RED, even if you're just a hardware person, not a software person, Node-RED runs on anything from a Raspberry Pi, on your laptops, on the cloud, 100% open source. There are nodes for GPIO and all sorts of the edge devices. And in the cloud, there's nodes for doing all the sorts of analytics. And you can prototype and build applications literally in minutes. I'm not going to I'll go through these very, very quickly, so I can hand over to Nick. But we're now using MQTT in a lot of our IBM-based solutions. Lift manufacturers sending data where they are basically analyzing the lifts and predicting there's going to be a problem, and so they can send out maintenance engineers and actually replace the relevant parts before the lift is actually out of action. So that's predictive analytics is a really big one for IoT. Whirlpool are actually connecting up their white good appliances using MQTT. And again, using it for customer service, making sure they can keep the goods running reliably and not breaking down. Connecting up power boats and getting the data to the engineers, but also to the spectators, so the spectators can see what's going on in the cockpit. Live dashboards. Chamberlain are using it for very low power devices like garage door openers. So again, very small, low footprint, very cheap devices. We have evolved MQTT. We shipped MQTT version 5, the standard, earlier this year, and it is just an evolution of the base one. MQTT version 3 is actually what most people are using. This just adds some areas to help scalability. So we said 10,000 devices in the early days. We want to scale to millions of devices now, and that's where a lot of the MQTT focus went. And the last I'm going to say before handing over, because actually, Thingstream actually don't use MQTT version 3, they use MQTT SN, MQTT for sensor networks. All of the same design goals apply to what we talked about earlier, but actually all of the implementations I've talked about of MQTT so far, they've run on top of a connection-based system on top of TCP, which adds some of the reliability. But there are a lot of networks that you can't sustain TCP, where you only might have UDP, it might be USSD, it might be Zigbee, so they're not connection-based systems. So basically, MQTT-SM was designed to run on these non-TCP networks, plus all of these other constraints. And it's much, much lower footprint again, which enables it to run on even smaller devices. So, sort of just to lead up for handing over to Nick, what Thingstream have done, you've got your devices with basically an MQTT SN client that runs on the device. It talks MQTT SN, please correct me if I'm wrong, Nick, either UDP or across USSD, which is a signaling profile for GSM, into basically an MQTT server. And I've said edge of network here. I should have said edge of network can be literally out at the edge of the network, or it can be actually in the enterprise itself. So it doesn't mean it's right at the edge of the, oops, sorry, apologies for that, at the edge of the network. And then you typically have connectivity hubs here, which is basically what Inflow Nick will be demonstrating, that can then bridge into solutions and backend systems like IBM's IoT backends, and then all the rich analytics that actually go beyond that. So I'm going to stop there. And in the spirit of Brexit, I'm not going to only speak English. I'm going to say thank you in many languages. And I am going to hand over to Nick. Thank you.
Just unlock that.
And in the spirit of cooperation, Nick's using my laptop.
Thanks, David. Right, so I'm going to sit down for this. There's no slides for this part. It's just more of a demonstration of how you can use MQTT in Thingstream, how you get the data. You've built your device, it's sending data in. Now, what do you do with it? So we have within Thingstream this concept of the data workflow tool. So will look very familiar to you from David's slide, as the front end of this is Node-RED. We've taken that because it's very widely used in the IoT space. And as David said, it's super simple. You just drop nodes onto your flow, connect them up, and you can do some quite interesting and clever things in a very short space of time. We've actually taken this one step further by the back-end processing on these nodes. We've rewritten in Java, so that allows our flows to scale up and to be able to run for millions of devices concurrently, which is something that you couldn't do with pure Node-RED. But we're able to, so we've taken a subset of the nodes that are available, rewritten that back-end in Java, and then dropped them into here. And we're able to quite quickly port nodes from Node-RED into the flow. So as you come across things, if you do work with Node-RED and you find functionality that you use regularly in your edge systems, and you'd like to replicate that in Thingstream, we can very quickly and easily take Node.js nodes and port them into Thingstream and make them available. So we'll have a look at some of the stuff you can do with topics. Within Thingstream, we have a number of system topics, which are predefined things that will fire events based on common things that happen. So things like when you deploy a flow, when you add a new device to the platform, when that device is first seen by the platform, all trigger system events in Thingstream, which you can, using an MQTT client, subscribe to then use for monitoring what's going on in your IoT domain. So if you were interested in keeping an audit history of when changes are made to flows, who's changing a flow, saving it, redeploying it, there's a system topic for that which you can subscribe to, and that allows you then through your other back-end systems to maintain audit history of the Thingstream domain. Something else that's really useful that you can do is with this device first connected event. You can use that to configure devices when they go out into the field. So these Thingstream buttons that we have when they come out of the box work on, they only send data when you physically press the button. But they have support in them to be able to send data more regularly. It can change the type of data that it sends, so whether you have GPS location or just cell location or no location at all. And the frequency that you send it at. And we had a customer who had bought a number of these buttons for a specific use case. They didn't want the location at all. So if you think about when you press this thing, it fires up, it tries to get a GPS lock, it then does a cell tower scan to pull in details of the 5 strongest cell tower signals that it can find, and then it publishes that data. Now that all takes a fair amount of time. You've got a 30-second timeout for GPS lock, you've got 25-30 seconds for a cell scan. And if you're not interested in location, you don't want to have to wait that time, you just want to press the button and have your message sent. So we use this device first connected topic to change the configuration on those devices. So they leave the factory in the box, all configured for to fire on press. What we then have in here is a flow deployed to the device first connected topic, which just through this simple little bit of JavaScript in here has a message topic and a payload that it can send. So I'll see if I can do an example. You may not be able to see it because of the light. So I've pressed this button now, and this is in its normal out-of-the-box mode. It will go through now, and it's doing its GPS lock, and we're sort of waiting for all that stuff to happen. And we'll see in sort of 20, 30 seconds' time that the message will arrive in here. It will trigger this first connected topic, which will run this flow and send a message back to the button with the new configuration settings. So we'll be able to see, where are we going now? Yep, so now it's into its cell tower scanning state. It will go through that, and then it will come into the publish mode. So already we've seen that we've sort of sat and waited 20, 30 seconds for this thing. Now it's completed that cellular connection. Now it's gone into publish, and we'll see this debug information appear in the flow in a second. And while it's doing that, if I go into the device itself, into the activity tab on here, so I can keep an eye on. So you see now this queued message indicator's gone up. So my flow has run. Here's my debug output, and it's saying publish a message back to this topic, which is a topic which is specific to the device itself, and telling it to flash LED green. And if we look at the button now, you probably can't see, but the LED is flashing green because it sent that message back. It's updated the configuration on the device, and it's now received those new settings. So you can dynamically change what the device does remotely, all using MQTT topics. So the next thing I wanted to show you is how easy it is to get data out from Thingstream into another back-end system. Let me just go into this flow here. So this flow is one that we've created, which takes the data from a button, runs through some of the logic in here, and then publishes that data out to the Cumulocity platform. So Cumulocity provided by our partner Software AG. This is my Cumulocity tenant, and I can see in here that I have a bunch of devices already registered in Cumulocity. But at the moment, this button is not part of that system. So if I deploy my flow, oh, hang on a second, where did that go? Why is it doing that? So what I've done there is now deployed that flow to listen to the MQTT topic that the device is publishing to. Now when I hit the button again and it sends the data through, it will run through this set of logic. And what this is basically doing is it's picking up the payload from the device. It then decorates that with the device's client ID, which it picks up from the platform. And it then prepares an event message. So if we have a look at this JavaScript node, so you can tell I'm not a Mac user. There it is. So this node is building out a message payload to send into Cumulocity, and it's using Cumulocity's smart templates, which are available in two flavors. There's one which is a REST API based, and this one that we're using, which is actually MQTT. So this is calling a template on Cumulocity, template number 400. It's identifying a device type of button, and then there's a message. And this will appear in Cumulocity as an event. And these are completely flexible. You can do whatever you like with them. On top of that, it also goes through this second set of the flow, which looks at the payload of the device and says, does it have GPS location or does it have GSM location? If it has GPS location, it takes this path through. builds out the publish message for a location update event and fires that into Cumulocity. In this case, it's actually firing 3 different Cumulocity smart templates. One which registers the device on the platform, one which updates it with an ID, and then one which gives it the location update event. If there was no GPS location available, it takes this second path through the flow, which grabs the cell tower information, passes that into our cell location service, which then goes off and calculates a position based on the location of those towers. And it then goes through another set of JavaScript to take that calculated location data and send it into Cumulocity. And the Cumulocity publish itself is just done through this native MQTT node, which if I fire it up, which is just configured with details of the Cumulocity tenant, the port number, the server name, username and password, and that sends through. So you'll see now on my debug node here, I've got the JSON payload which came from the device, saying that the button was pressed. If I go into Cumulocity and just refresh this list, we'll see now I've got a new device that's been added to my Cumulocity tenant called prescription button, and I can go into that and look at the events for it, and I can look at location, and I can see there it is, and there's my location here in Amsterdam. So very quickly and simply, you've got a flow which takes a device and dynamically registers that into your back-end system, updates it with other pieces of information, some of which have come directly from the payload of the device. Others, things like the name of that device, have been taken from the data that's the metadata for the device in Thingstream and then passed through to the back-end system. And we have, so this is using a native MQTT connection. We have the same thing for HTTP, so you can do posts out. And we also have some strong type connectors that we've built for systems. So we have, if I can just find the scroll bar here. Okay, I can't find the scroll bar. But within the palette here on the left-hand side, there's an output section, and in there we have connectors for IBM Watson, Microsoft Azure, and we're building out more of these connectors as new customers come on board with new backends that they want to get data into quickly and easily. So we can just build those out, and then you can very simply configure that with the credentials for the system that you want to get to, and send that data out to it. Something else that you can do with flows, if we look at this one. So you can then start to get quite clever with your flow. You can do all sorts of stuff. So this flow is for a use case where the button is being used in a shop for reordering stock. So this uses, let me just go into my thing properties. So as part of the metadata for that device, you can configure a number of properties which you can then refer to in a flow. So in this case, I've set up an email address, there's a last seen timestamp, there's a phone number, there's a JSON object which contains the details of the order that would be placed when you press the button. So a whole load of different properties in here to show product identities, how many of those you want, and what the unit is. A customer code and a customer name. And these can be put together in a CSV file and uploaded into the platform so that you can have, if you have 1,000 different devices, you can do all of that in a file and just upload it quickly in. You don't have to come in and physically type all this stuff in. So then within my flow, let me just deploy it. So now within my flow, I've got a whole load of different logic that will look at those device properties and take action based on the values that it sees. So in the first instance, when I press the button, nothing has happened yet in the world of my order. So this is a completely new request from the shop saying that they want to get some new stock. So this will come through in my function node here. I have a load of logic which looks at the variables stored for that device and then works out what you want to do. So the use case in here is that you press the button, you'll get a message back to say, okay, we've received your order, press the button again to confirm. As it does that, it updates the properties for that thing to give a new indicator to say that the button's been pressed. So that the second time the button comes in, it can take a different path through the flow based on the variable that you've reset, and then confirm that order, and then it will go through and do a number of other things, such as this is doing a confirmation check. And you see now it's saying requesting confirmation, and on my phone here now, I've received an SMS which just says, thanks for your order, press again to confirm. So now if I press again to double check, you'll see that in my thing properties here, the order press count has now gone up to 1 to indicate the button's been pressed once, and now take the second path through the flow. And it will now go through this process order confirmation step, which we'll see fire up here in a sec when that completes. Let it go through. And it will then send a second SMS to say, okay, we've got your order now, it will come through. It builds a file which is FTP to a server which the logistics department can pick up to handle the shipping. And it sends an email back to the customer to say, thanks, that's it, I've got your order. So you can build in a lot more logic into the application here in the cloud. And a flow like this probably takes, I don't know, maybe an hour to put together, test and run, and then you're good to go. So just from very simply and quickly, you can build quite complex logic flows to make your devices behave in ways that maybe they weren't originally designed to do. So this was designed as a tracker, but now I'm using it for order purchase and things like that. Okay, so that's it on flows. We'll have a look at the questions. So the first question, how secure is MQTT versus IP? David?
It's a really good question. So we should have said security is really important on any IoT application. And actually, when we invented MQTT, most people didn't even think about security because actually the connectivity was over private networks into closed systems. And of course, that was really bad because what happened was the operation systems ended up being linked to the more traditional systems, opening a hole to enable the two different types of systems, the IT and the operation systems, to talk to each other. That doesn't actually answer the question, but needless to say, we are seriously thinking about security with MQTT. Most of MQTT runs over TCP, so we rely on, first of all, network security using SSL and TLS. So the key, again, with having MQTT based on there is every time there's an improvement in TCP and the security standards, like we're at TLS 1.3 now, MQTT benefits from there. Also, the iterations of MQTT from version 3 to 3.1 to version 5 have added security features as well. So from our perspective, security is absolutely vital, but it has to be coupled with the security, with crypto stores or with the SIMs also, so we end up with an end-to-end security chain and provenance of the data. The key is provenance of the data.
Yeah, and also when you look at the way that data is transmitted with Thingstream, going over USSD and UDP, we use the identity of the SIM as part of the authentication for that device. And the data is traveling through the signaling layer of the networks, which is inherently very secure. arrives at the network, and is then sent through a secure VPN into Thingstream. The SIM identity is provided by the network. It can't be injected by anyone else. So we have a very secure IP-less state for that. And then your data comes into a flow, you work with it, and fire it out to your back-end system over normal internet with SSL, TLS encryption there. So it is an inherently secure
Bottom line is make sure when you're building any solution, you think literally end-to-end from a security perspective.
Absolutely. Second question. What are the best strategies to scale MQTT up to millions of devices?
So again, there isn't a simple answer to that. It comes down to the architecture of the network. So a lot of the time, you have lots of devices at the edge of the network. They will come in via your sensor area network, so they come into the first concentration layer, which is your edge gateway. So again, you can have hundreds, thousands, tens of thousands even being concentrated at the edge. And then basically you end up with a single bridge from the edge gateway up into the cloud or the enterprise. So you're now multiplexing those large devices from the edge into the cloud. So that's absolutely one strategy. If you're having direct connectivity of devices into the cloud, a lot of the MQTT servers now in the enterprise, in the cloud, actually scale up linearly. So rather than just one monolithic MQTT server, they scale across the cloud. So it comes down also to the choice of MQTT server that you use. And then, of course, there are going to be network constraints. I would suggest, actually, if you're running over GSM with the inflow solution at MQTT-SN, that is purely down to the scalability of GSM, the network. Yeah. And then I believe the inflow server is, I won't say infinitely scalable, but highly scalable in a linear fashion.
Yeah, absolutely. So the Thingstream broker itself is running in Amazon, in AWS. Which has full, say that word, has full auto scaling. So as the load ramps up on the server, we scale out more machines to handle that. So not quite infinitely scalable, but incredibly scalable.
And the only other comment is, of course, the power of devices at the edge. And I don't necessarily mean the true little devices right at the very edge, which are tiny little controllers, but the edge gateways are getting more and more powerful. So we're actually starting to see the trend of deploying more and more logic out to the edge of the network. And that logic can be rich AI logic, like visual recognition. So you already do that with number plate recognition, as an example, in cars. So what you're starting to see is you don't have to send everything into the cloud where you're running all the really sophisticated analytics. We're doing machine learning, we're doing AI out at the edge of the network. That's a big trend moving forward as well that helps with scalability.
Yeah. And one other point in scalability, so we talked about the nodes in the flows that we have having been rewritten in Java. And what's actually happening behind the scenes when you trigger a flow is that those nodes are firing up as almost little virtual machines of their own to handle that processing. So as you have tens of thousands of devices hitting the server and firing up the flow, we're firing up tens of thousands of little micro machines in the back to handle that processing. So again, that helps it to scale to a high level. Next question. Can you use MQTT for streaming data, e.g. audio? Well, absolutely, you can.
You can. I will say it's not. We've done audio, we've done video, we've even done FTP on top of MQTT. We've done all sorts of things. That wasn't actually what it was designed for, because you basically have to create packets and etc., break it all up. But there are other protocols that are better for doing streaming of audio and video. But it has been done.
Can MQTT help me with over-the-air firmware updates for my IoT node? I'm not 100% confident with my firmware. Well, absolutely, and we have customers doing exactly that. So they'll have devices which are subscribed to a firmware update topic, and then when you want to publish firmware to your devices, you simply fire an event to that firmware update topic to say, I've got new firmware, and that triggers the device to then go and pick up that firmware. Yeah. So a really great use of topics there. And you can have using the topic hierarchy that we looked at earlier, you can have a firmware topic, and then you can have subtopics to relate to a specific device or a specific version of firmware and things like that. So the devices can learn from that. And they can also dynamically update the topics that they're interested in listening to. So again, you could send a message to the device to say, now you want to listen to topic for firmware X, and it will update itself to do that. So whenever you subscribe to it, you're good to go. To actually send the payload itself over MQTT-SN? Well, so you can do it in a number of ways. The SDK that we have deals with message concatenation. So although a USSD message is limited in terms of its size, you can send a payload for a firmware update over multiple MQTT-SN messages, which the device can then put back together and build. And we have so we have a customer who is doing exactly that. I think their firmware update goes over something like 20 message packets. They're not interested particularly in how long it takes to get there, just that it does. So they, using the MQTT quality of service, they know that message, they can set that to an appropriate level to guarantee the message delivery, and then it can just sit and build that message together over however long it needs. And then fire that firmware update in once it's loaded.
So you have to. There are always constraints. Like I say, if you can only send a certain message size because of the limitation, then you will have to break it down. What I would suggest is there is a strategy which is minimize the number of over-the-air updates by actually parameterizing a lot of the configuration data, etc., actually in the firmware itself. And then it's easy to send down configuration updates and tweak it. But in the end, sometimes you will need to do over-the-air patching. And again, maybe you patch it rather than send down a whole update.
David, did Eurotech co-develop MQTT with IBM?
They did. So it was actually Arcom Systems at the time that then got taken over by Eurotech. So it was my colleague in IBM, Andy Stanford-Clark, who's now the CTO in IBM UK, and Arlen Nipper, who was the CTO for Arcom Systems.
And then last one, what about the order of receiving messages? Is that the same as the order of sending?
So that
an interesting question.
I will come back to you on that because I can't remember the official standard answer to that because different implementations have done it different ways. So let me come back to you with the official answer from the standard.
Yeah. In terms of Thingstream, with a message, if you think about a message coming, like configuration message going to the device, then we do queue those messages and send them in the order that they're received and published in. So in that respect, the ordering is controlled.
I will say most implementations will do that, but I can't. There isn't I need to just check the official standard.
Yeah. Okay. And in MQTT, any distance or network matters? I'm not sure. Who asked that? Can you elaborate on that question?
Any distance or limitations? Limit of distance. Networks limitations.
No, not at all.
So again, if you were using MQTT-SN over GSM or over UDP, it's purely down to the GSM network. And you've already heard, I think, that there's pretty much 99.9% worldwide coverage. And in the case of other networks, when you're running on top of TCP, as long as we can get a TCP connection, even over a very, very slow network, it will go as far as TCP will reach.
Yeah. Okay. Thank you very much.
Thank you.